Okay, in this video, we'll talk about graphing parabolas. You will need to remember that there's the two forms. One has the x squared and the other has the y squared. And you somehow have to remember that the ones with x squared are the ones that will either open upward or downward. The y squared ones open left or right. Everyone has their own little ways. For me, the ones where x is squared, those are the ones that you first learn about. Starting back in Algebra 1, they only open up or down. Those are the ones that are functions. They pass the vertical line test. Versus the ones, if you have y squared, it's not going to pass the vertical line test. Two different y values could give you the same x value. Okay, so let's start off with this example here. We've got x squared equals 12y. Okay, so in this one, the x is being squared. So this is going to be one that's up or down. Now, for me, when I see that this is positive, then I know that it's going to be up. Okay. You can also reason that out from the value of p, which we'll talk about in a minute. Okay, so this fits the formula that x squared is equal to 4 times p times y, and 4p is equal to 12. So you just write 4p equals 12, divide both sides by 4, and that tells you that p is equal to 3. All right, so p is going to be the distance from the vertex, and for right now we're going to have the vertex be 0, 0. So it's from the distance from the vertex to the focus. Okay, so we have our vertex being 0, 0, and you can get to the focus by going 3 units, and that's a positive 3, so you can go up 3. All right. If p had been a negative number, then you would go down 3. Okay, now once you know that's where the focus is, and that's like inside the parabola, then you know the directrix is the other direction. So it's technically the opposite of p, or negative 3. I like to just think of this being 3 units, and then to the directrix will be another 3 units. So technically this is p, and that's the opposite of p. Okay, and then you want to get 2 specific points on the parabola. You've got the vertex, but you want 2 other ones. You know it's going to open this way. So go to your focus and count 2p, or 2 times the absolute value of p. So p is 3. 2 times 3 would be 6. So go 6 units to the right. 1, 2, 3, 4, 5, 6. That's a point on the parabola. Go back to the focus and then go 2p units the other way. So 6 units to the left. 1, 2, 3, 4, 5, 6. All right. And then those 3 points are on the parabola. Now, if you want to check yourself, you can take one of those points that you came up with, like this one here. Excuse me, the coordinates are 1, 2, 3, 4, 5, 6, 1, 2, 3. So that's the point 6, 3. You could check that in the original equation. So we're going to check 6, 3 in x squared equals 12y. So you're putting in 6 for x and 3 for y. So 6 squared should equal 12 times 3. So 36 equals 36. So yes, it works. Okay, let's try one other one. So, okay. This one is y squared equals negative 8x. Okay, so in this one, when you see the y is being squared, this is the kind of problem it's either going to open to the left or to the right. And if it's a negative coefficient, it's going to open to the left. Okay. All right, so you want to compare it to the basic form, y squared equals 4px. So the coefficient -8, that's the value of 4 times p. So you can just write that down. 4p equals -8. Divide both sides by 4. This tells you that p is -2. Now, a lot of times when I'm graphing, you're going to see me just count 2 spaces, but officially p is a negative number. Okay, so you can start at your vertex and basically go 2 to the left. That'll be -2. So, like I said, we're going to have the vertex be 0, 0. And then if I go 2 to the left, that's the focus. All right, so remember, the focus is inside of the parabola, so to speak. So that's the basic idea of the parabola. And then the directrix is going to be 2 spaces to the right of the vertex. All right, some people don't put in the actual directrix and the focus because they're not really part of the graph, but I draw it as a dashed line because I think it's very helpful. Okay, now you just have the 1 point so far in the parabola. You want to get 2 other ones. So this time we'll be drawing a vertical segment here. Okay. The actual name of the segment is the latus rectum, and its length is the focal diameter. So this is where we take the value of p, or make it the absolute value. P was 2, so the absolute value of p is +2, and 2 times that. So 2 times 2, that'll equal 4. That's the focal, I'm spelling that wrong, focal diameter. Well, actually, it helps you find the focal diameter. So we'll go from the focus, count 4 this way. 1, 2, 3, 4. That point is on the parabola. Go back to the focus and then count 4 this way. 1, 2, 3, 4. That one's also on the parabola. Okay, so we can draw in the graph of the parabola. Okay. So it's not going to really work out to be a big deal, but just to make sure you're clear, this length here is actually 8. That's the focal diameter, and the segment that it belongs to is the latus rectum. All right. Here's the graph.